Imagine this. Right now, at the very center of the Milky Way, something invisible is shaping the motion of hundreds of billions of stars. It emits no light. It makes no sound. It cannot be seen directly. Yet its presence defines the structure of the entire galaxy we call home. Our story begins on Earth, a small, fragile world orbiting an ordinary yellow star, the Sun. The Sun is just one of hundreds of billions of stars inside the Milky Way galaxy, located on the outskirts of a quiet spiral arm. From here, the universe feels calm and familiar, but appearances can be deceiving. The Milky Way is vast beyond imagination. It stretches over 100,000 light-years across, with swirling spiral arms made of stars, gas, and dust. And every one of those stars, including our Sun, is slowly orbiting a single point, the galactic center, a region located about 26,000 light-years from Earth. If we could begin a journey away from our planet, we would pass beyond the orbit of Neptune, leave the solar system behind, and enter the deep interstellar void. As we travel inward through the Milky Way, the number of stars steadily increases. The night sky grows brighter. Space becomes crowded, turbulent, and alive. Nebulae glow with newborn stars. Ancient stellar clusters drift through clouds of gas. Radiation and gravity grow stronger with every passing light year. Yet the closer we get to the center, the harder it becomes to see. The heart of the Milky Way is hidden. Dense clouds of interstellar dust block visible light completely, rendering optical telescopes nearly useless. From Earth, the galactic core appears as a dark, empty region in the sky. For centuries, it remained a mystery. To uncover what lies there, astronomers had to look beyond visible light. They turned to infrared, radio waves, and X-rays. These invisible wavelengths can penetrate thick dust, allowing us to peer into regions once thought unreachable. And when scientists finally looked through that cosmic veil, they saw something extraordinary. Stars near the galactic center were moving at incredible speeds, thousands of kilometers per second. Their orbits were tight, fast, and highly curved. Something massive was pulling on them. But there was a problem. No visible object could explain such powerful gravity. No star was large enough. No cluster of matter was dense enough. The only explanation left was both radical and unavoidable. Sagittarius A, a supermassive black hole lurking at the exact center of the Milky Way. Sagittarius A contains a mass about 4 million times greater than the Sun, compressed into a region of space smaller than Mercury's orbit. It is gravity pushed to its absolute limit. Yet despite its immense power, it does not behave like the monsters of science fiction. Black holes do not roam the universe, devouring everything in sight. If the Sun were replaced by a black hole of equal mass, Earth would continue to orbit normally. What makes Sagittarius A extraordinary is it not how aggressively consuming matter, but how massive it is and where it resides, at the very heart of the galaxy. The strongest evidence for its existence comes from tracking individual stars. One of them, known as S2, orbits Sagittarius A once every 16 years. At its closest approach, S2 races through space at nearly 3% the speed of light. Only a supermassive black hole could force such an extreme orbit. For decades, Sagittarius A remained unseen. Until 2022. That year, humanity achieved something remarkable. Using the Event Horizon Telescope, a network of radio telescopes spread across the Earth, scientists effectively turned our planet into a single, gigantic telescope. The result was historic. For the first time, we captured an image of the shadow of Sagittarius A. Not a drawing, not a simulation, but a real photograph of a black hole's silhouette. The image revealed a glowing ring of superheated gas circling at nearly the speed of light, surrounding a dark central region. That darkness marks the event horizon, the point of no return, where gravity becomes so strong that not even light can escape. The image matched Einstein's predictions with stunning precision. General relativity had passed yet another cosmic test. Today, Sagittarius A is considered a relatively quiet black hole. It consumes very little material and emits only faint radiation. But this calm state is not guaranteed to last forever. If large amounts of gas or dust were to fall towards Sagittarius A, it could awaken. The black hole would begin feeding rapidly, releasing enormous amounts of energy. Powerful jets could erupt from its poles, stretching thousands of light years into space. The Milky Way's core would transform into an active galactic nucleus, bright enough to outshine billions of stars. It sounds terrifying, but Earth would remain safe. The distance is simply too great. Sagittarius A cannot pull us in, and its radiation would weaken long before reaching our planet. The true danger lies not in destruction, but in misunderstanding. Sagittarius A is not a cosmic predator. It is a fundamental part of the Milky Way's structure, helping stabilize stellar orbits and shaping the evolution of the galaxy itself. Without it, the Milky Way might look very different. By studying this black hole, we are not only learning about distant space, we are probing the limits of physics, testing our understanding of space and time, and uncovering how galaxies are born, live, and change. We live on a small planet, orbiting an ordinary star inside a galaxy governed by something we cannot see. At the heart of it all, a silent giant bends the universe around it, and our journey to the center of the Milky Way has only just begun.